All right, problem number 5 in set number 7. We're given a lock that has 5 buttons and they're numbered 1 through 5. The lock is opened by pushing 2 buttons simultaneously and then pushing 1 button alone. How many combinations are possible? Okay, so let's draw a little picture here just to see what we're dealing with. So I'm going to draw 5 buttons. There's 1, 2, 3, 4, 5, and they're numbered 1, 2, 3, 4, and 5. So we're told that in order to get this lock to open, we have to push 2 buttons simultaneously, and then we push 1 button alone. Okay? So one way that you probably need to divide this problem up into 2 parts. First of all, look at how many different ways you can choose 2 buttons from these 5. And in this case, order doesn't matter because you're pushing them simultaneously. So if you push the 2 and the 3, that's the same as pushing the 3 and the 2, right? Because you're just pushing them simultaneously. So in that case, the order doesn't matter. And then the second part. So once you find out how many ways that you can choose 2 buttons from 5, then look at how many ways you can choose 1 button alone. Well, that's not too hard because you have 5 choices. So you'll have 5 choices for choosing 1 button alone. And then once you have that, you can look at how many different ways, that you'll have a number of different ways to choose the 2 buttons and a number of different ways to choose the 1 button alone. So then you can figure out how many ways you can choose the 2 things. Choose the 2 buttons and then the 3rd button alone. Okay, and in that case, order will matter because you're doing it in a sequence. So you push the 2 buttons and then you push the 1 button. Okay, so hopefully that clarifies the problem for you. And so I'm going to go ahead and solve this. Alright, so first of all, let's look at the number of different ways that we can choose 2 buttons from 5. And order doesn't matter. So the easiest way to do it is to use a combination and just say 5 choose 2. But 5 choose 2 does not have a line. Whoops. So it's just 5 choose 2 in parentheses. That's how you write it. And we have 5 choices for the first button, and then we have 4 choices for the second button, and we have 2 ways to arrange those buttons. So we have to divide out the duplicates, okay? Because 1 and 2 is the same thing as 2 and 1, okay? So that gives us 20 over 2, which is 10. So we have 10 different ways that we can choose 2 buttons from 5. Okay. Another way to look at it, if you draw a table and you label you make the rows 1, 2, 3, 4, 5, and the columns 1, 2, 3, 4, 5. Then each one of these, if you were to draw a grid on here. You could look at all the combinations, but if you need to push 2 buttons, so you can't push 2 ones at the same time. That would just be pushing 1 button. So the 1 1, the 2 2, the 3 3, the 4 4, and the 5 5 are not options. And then the 1 2 and the 2 1 are the same. So we can actually eliminate this half of the table because it's just going to be a duplicate of what's above. Okay, so really we're just looking at this that would say the 1 2, the 1 3, the 1 4, the 1 5, 2 3, 2 4, 2 5, 3 4 3 5, and the 4 5, which should be 10, right? There's 4 7 10. Yep. So that's another way you could do it if you don't know combinations. Combinations is very good thing to learn. So because they make things a lot easier. All right. But now we have the number of ways that we can choose 2 buttons from 5. And now we know that there's 5 choices for the single button alone. So we can actually take, so we have 10 choices for the 2 button combination, and we have 5 choices for the 1 button alone. And in this case, it makes a difference what order you do it. So that's just going to give you 50 ways to 50 different combinations to this lock that are possible. So the answer is 50. All right?